Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam, whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Hook. This one simple Surds step cost more candidates marks than any other on last year's papers. Picture this. A student cancels a square root wrongly and loses 2 method marks in under 10 seconds. Sound familiar? You need to hear the 3 small moves that stop that happening.
I remember that panic. You look at the root sign and your brain blanks. How do we stop that?
Exam snapshot. Surds and fractional indices show up across AQA, Edicel and OCR, because they're a great way to test algebraic manipulation and exact answers. The recurring pattern examiners spot is not that students don't know the rules, it's that they don't write the reasoning down. The maths is straightforward if you convert carefully and use prime factors. Write the steps, the marks follow. Right, today's concept section. One topic, clear and step-by-step. We'll cover 3 things. 1. Converting between surd and index form. 2. Using prime factorisation to simplify or compare. And 3. Rationalising denominators when required. No jargon first. Think square roots for surds and powers for indices.
Can you give a tiny example first? Something I can say to myself when I see a root.
Absolutely. Simple rule. The square root of a number is that number to the power 1/2. So root a is a to the power 1/2, written a to the power 1/2. That link, surd to fractional index, is the bridge we use to combine and compare expressions. Picture it. Turning a radical into a power gives you algebraic rules that work every time.
Now, prime factorisation. If you want root 72, prime factorise 72 first. 72 equals 2 to the 3 times 3 squared. Then root 72 equals 2 to the 3 times 3 squared to the 1/2 equals 2 to the 3/2 times 3 to the 2/2 equals 2 times 3 times 2 to the 1/2, which simplifies to 6 root 2. That step, pulling out perfect square factors, is the key.
So, you look for pairs of factors for a square, and anything left over stays under the root. That actually sounds doable.
Exactly, and fractional indices help when you need to compare sizes without a calculator. For example, 8 to the power of 2/3 is 8 to the power of 1/3 squared. Since 8 to the power of 1/3 is 2, that's 4. Turning surds into fractional powers lets you apply power rules. A to the m times a to the n is a to the m plus n, and a to the m to the n is a to the mn. Keep those rules in your toolbox. When to simplify and when to leave as surds. If the exam asks for an exact answer, or simplest surd form, always simplify prime factors and remove perfect squares from the root. If the denominator contains a root, you're often asked to rationalise, remove the root from the bottom, because marks are given for clean final form.
Worked example time. I'll read the exam question and then we solve it step by step so you can copy the sequence into your answer book. Question. Simplify and rationalise the denominator of the expression square root 72 divided by 3 square root 2. Give your answer in simplest surd form. Write it down as you hear it. That's what examiners want.
Okay, I'm ready. What's the first move?
Step 1. Simplify the numerator using prime factors. We already did this. Root 72 equals 6 root 2. Write that explicitly. Root 72 equals 6 root 2. That gets you the first method mark, because you've shown understanding of surd simplification.
Step 2. Substitute into the fraction. So the expression becomes 6 root 2 over 3 root 2. Now look for cancellation. Because both top and bottom have root 2, you can cancel them, but cancel only after writing them clearly. Cancel root 2 to get 6/3, which simplifies to 2. So the result is 2. Wait, that means the whole expression is just 2. No irrational left. That's neat.
Yes, this is a classic trap. If you cancel before simplifying, you might do it incorrectly and lose marks. Write the simplification, then cancel identical surd factors. Also note, when cancellation removes the surd entirely, you don't need further rationalisation. Write the exact final answer, 2, and box it.
Let's show an alternate route using indices, because examiners often reward either approach. Convert root 72 to 72 to the half and root 2 to 2 to the half. So 72 to the half over 3 times 2 to the half. Prime factorise inside. 72 equals 2 to the 3 times 3 to the 2, so 72 to the half equals 2 to the 3 to the half times 3. The denominator is 3 times 2 to the half. Cancelling the 3's leaves 2 to the 3 to the half over 2 to the half, which is 2 to the 3 to the half minus 1 to the half equals 2 to the half, which is 2. Same clean result, different notation. Either route is fine. Show the steps.
That index subtraction step is satisfying. It's like cancelling powers. I can hear examiners asking for either primes or indices. Exam technique, how the marks are awarded for this sort of question. Typically, it's 1 mark for a correct rewrite or simplification step, 1 mark for showing cancellation or use of indices, and 1 mark for the correct final exact answer. Call it M1, M1, A1. If you show root 72 equals 6 root 2, that's M1. If you show the fraction 6 root 2 over 3 root 2 and cancel correctly, that's M1. The final boxed 2 is A1. If you can't finish, those early steps often secure the method marks. Write them down. Write it down. Don't just think it.
What common mistakes lose marks here?
3 common slips. 1. Cancelling without showing the surd factorisation. Examiners can't award method marks if the work isn't written. 2. Incorrect prime factorisation. Be systematic with powers of 2, 3, 5, etc. 3. Trying to rationalise when the surd cancels and you don't need to. Extra steps can introduce sign or arithmetic errors. Keep it tidy and justified.
Quick win. A 30-second checklist you can use in practice or in the exam. 1. Prime factorise any number under a root to pull out perfect squares. 2. Rewrite surds as fractional indices when combining or comparing powers. 3. After simplifying, substitute a quick decimal check to make sure the answer is sensible. That's 10 to 20 seconds and catches most slips. Do those 3 actions every time you see surds.
So my checklist is prime factors, indices if needed, and a quick substitute check. I can do that under timed conditions.
Recap in 1 sentence. Convert surds to indices when useful. Pull out perfect squares via prime factorisation. Cancel carefully and only rationalise if the root remains in the denominator. That's how you keep method marks and get the exact answer. Let that sink in.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Send us your tricky surd questions and we might use them in a future episode. Stay curious.
Thanks. I'm going to practice that checklist straight away. See you next time.
Until next time, trust the process and nail that exam.